I have taken some of the geometry, for example, rectangular, some in case of ring shape, L shape, and this is basically a triangular shape. Okay. So the first note point is the center of mass may lie inside or outside of the body. Outside of the body. Very, very important point. So always remember the center of mass will not always lie in the inside of the body. It may also lie outside of the body. Okay. Now you can see here for the L shape section, I will talk about later on. I can divide this L section in the two form and we can calculate the center of mass for a composite system. Okay. So right now only I am discussing some of the key points and later on I will discuss this composite system also. Center of mass may lie inside or outside of the body. The second point is the position of center of mass depends on the shape of body. Shape of the body. Okay. Center of mass position is also dependent upon the what kind of shape will be there in the body. Okay. Third one will be for the given shape of body. For the given shape of body, for the given shape of the body, the center of mass, it depends on the how the mass is distributed. Depends on the distribution of mass. Distribution of mass within the body. Within the body. And it is closer to the heavier side. It is closer to the heavier side. Okay. So that means for a given shape of body, the center of mass is also depends on how the mass is distributed within the body. If the mass, for example, let us suppose this will be the shape. If more mass will be here, so the center of mass will not exactly at the center. Okay, it is closest to the heavier mass. This is the meaning of third state. Okay. Now the fourth one, there may or may not be any mass present physically at the center of mass. Very, very important point. At the center of mass. Okay. So what I have mentioned. So once you locate the center of mass, and you will see later on also, there may or may not be any mass present physically at the center of mass. Now you can see here. So here at the center of mass, some mass is there, but at this point there is no mass. Okay. For a ring shape, the center of mass will be at this point. Okay. Where physically there will be no mass. Similarly for this L section also. Okay. Now the last one, which is nothing but for symmetrical bodies, that means whenever the body is symmetrical about some particular axis, you can see here it is basically symmetrical about the x-axis also, y-axis also. Okay. So for symmetrical bodies having homogeneous or we can say that a uniform distribution of mass, their center of mass will coincide with the its, or we can say that center of mass coincide with the center of symmetry. Center of the symmetry, or we can say that, or the geometrical center. That means if any body, if you see, if it is symmetrical about the x and y axis, the intersection point is the, or we can say that the center of symmetry is nothing but the center of mass, or also we can also tell the geometrical center will coincide with the center of mass. This is nothing but the centroid here. Here also b by 2 h by 2 for a cylindrical also, and this is for a cuboid. Okay. So these are the 5 important key point and the note point which I have discussed that will help you to eliminate the options. Now I will discuss some of the problems which was asked in the JEE exam. Two bodies of mass 1 kg, 3 kg having a position vector they have given. That means the two masses are there. First one is the 1 kg and 3 kg whose position vector is I cap plus 2j cap plus k cap minus 3i cap minus 2j cap plus k cap respectively. Okay. The magnitude of position vector of center of mass. So you have to calculate what is the position vector of center of mass. So what you will do? So to get the position vector of center of mass, you already know a beautiful relation which is nothing but m1 r1 vector plus m2 r2 vector. Here only two masses, so I am considering only two. So m1 plus m2. Now what is m1? M1 is given as 1 kg and m2 is given as 3 kg. Fine. M2 is given as 3 kg. So r1 vector, the position vector is nothing but I cap plus 2j cap plus k cap. That means these 2 point masses are located at 1, 2, 1 and minus 3, minus 2 and 1. So they have clearly mentioned in the position vector. So you can take as a r1 and r2. So r2 vector, can I say this value is minus 3 I cap minus 2j cap plus k cap. So if you want to calculate the center of mass of this position vector, the system of particle having the two masses 1 and 3 kg. So this value is m1 is 1 kg. So r1 is I cap plus 2j cap plus k cap plus what is the m2 value? 3 into minus 3 I cap minus 2j cap plus k cap divided by what is the total mass? 3 plus 1 is 4. So if you solve this, this is I cap and this is minus 9 I cap. So this is minus 8 I cap and this will be minus 4 j cap and 1 k cap plus 3 k cap is nothing but 4 k cap divided by 4. So you will get minus 2 I cap minus j cap plus k cap. So what will be the answer? The option D is the correct answer. And this question was asked in the JEE exam 2022. Okay. Very simple question. You have used the simple expression for the center of mass and you have kept the value of mass in the position vector. You got the answer. Okay. This is the first type of problem. The second type of problem I am going to discuss. Instead of giving the two masses, now if they have given these masses are located in some particular shape. Okay. That means the three masses of mass 50 grams, 100 grams and 150 grams are placed at the vertex of equilateral triangle whose side is 1 meter. The xy coordinate of the center of mass you have to calculate. Okay, so this is the basically equilateral triangle. That means all the sides are equal and these point masses m1, m2, m3 are located at 50 grams and 100 grams and 150 gram at the origin. And what is this coordinate? So first of all, you will find the coordinate of these masses. So the given mass m1 is equal to 50 gram, m2 is equal to 100 grams and m3 is equal to 150 grams. Fine. What will be the xy coordinate for these masses? The xy coordinate is nothing but x is 0, 0. And what about the m2 mass? That is 1, 0 and m3 mass is located. So can I say this point coordinate is, so equilateral triangle means this side is also 1 and this side is also 1. Fine. So if I want to find the position of this m3 mass, so if you take this cos component, so what is this? 1 cos 60 will be the x coordinate. That means this one. And what about this one? 1 sin 60. So I have resolved this 1 meter in the x and y direction. So 1 cos 60 and 1 sin 60. Fine. What is this value? So 1 cos 60 is 1 by 2 and sin 60 is root 3 by 2. Now you got the position of each and every mass. Mass is already given m1, m2, m3. Now you can use the expression for the center of mass. So RCM you have to use. That means m1 r1 vector, m2 r2 vector plus m3 r3 vector. Okay. So z coordinate will be 0 because these point masses are located in the xy plane, and the mass is m1 plus m2 plus m3. Okay. So what is the mass m1, which is 50? M1 mass is 50 gram. And what is the value of this R1? Can I say this is 0, 0? That means this term value will be 0 because their x and y coordinate will be 0. What is M2? M2 is 100. R2 means R2 position vector means 1 I cap plus 0 j cap. That means 1 I cap. So 100 into 1 I cap plus what is the M3? 150 into, so I will write here, plus 150 into 1 by 2 I cap root 3 by 2 j cap. What is the total mass? 150, 50 is 200 plus 100 is 300 gram. So this value will be nothing but 100 I cap and divided by 300. So this is 75 divided by 300, and this value will be 75 root 3 divided by 300 j cap. Okay. Now you can see here 100 plus 75 will be, so let me take, so what is this value? 175 I cap plus 300 plus 75 root 3 divided by 300 j cap. So if you solve this you will get as 7 I cap plus, so 7 I cap divided by 12, and this is nothing but 75 divided by 300, which is nothing but 1 by 4. So root 3 by 4 j cap. Okay, because if you multiply with 75 into 4, you will get the 300. So this value is 4 root 3 j cap and 7 I divided by 12, which is nothing but, that means the x coordinate will be 7 by 12 meter, and whatever the what is the y coordinate? Root 3 by 4. So which option will be correct? So the option D is the correct answer. Okay. So this question was asked in JEE 2019. Now let me take one more problem. So 3-point particles having mass is 1 kg, 1.5 kg and 2.5 kg are placed at 3 corner 1 kg, 1.5 kg and 2.5 kg, which is mass, located at 3 centimeter, 4 centimeter and 5 centimeter. The center of mass of the system is at point. That means you have to calculate again the center of mass. Very, very simple question. So this question was asked in 2020. Now, if you see the options, you have to locate the center of mass with respect to the 1 kg mass. So what you will do, you will take the reference as a 1 kg mass. That means this coordinate I am taking as a 0, 0. Let us suppose this is the center of mass. I want to locate the center of mass of these three system of particle. So from 1 kg mass, the x center of mass, can I say m1 x1 plus m2 x2 plus m3 x3. Okay, so you will get the x center of mass coordinate divided by m1 plus m2 plus m3. Similarly, y center of mass m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. What is the mass m1, which is 1, x coordinate is 0. This value is 3 into 1.5. Okay, and m3 is 2.5. x3 coordinate is 0 because if I want to locate this point, this coordinate is 0, 4. What about this? 3, 0, and that is 0, 0. Divided by what is the total mass? Total mass will be 5. So if you solve, you will get as 0.9 centimeter. Similarly, m1 y1, what is 1 into 0 plus 1.5 is the mass, and y2 is 0, and 2.5 into y3 is 4 divided by total mass if I will take as a 5. So this is nothing but 10 divided by 5, 2 centimeter. Now this position, x center of mass, y center of mass, you have calculated from the position of 1 kg mass. Okay, so that means this x center of mass and y center of mass is nothing but 0.9 centimeter, and y will be 2 centimeter above. 0.9 centimeter right and 2 centimeter above. That means option C will be the correct answer. So choice C is the correct answer. Okay, so in this particular session, I have discussed if these point masses are acting, how to calculate the center of mass of the system of particle.